Okay, from where we left off. Remember we had written our class as string, but now I changed it to net. And now we're ready to start defining every single thing now. And what exactly are we defining? This is what we'll be defining. An output, the number of hidden nodes and the features. The features are, remember what you created, the hidden nodes, and the output. So our main objective is to develop a graph that somehow looks like this but doesn't exactly look like this because they're always different. The main focus is to get as minimum error as possible so that we can be able to get the best predictions. Here's another graph. This is what there's a different graph. So you can see these are some of the predictions I do get. At some point ends up being stagnant. There's like no progress. So if you can see, you can reach here better, right? Get the around 200 to 400, between 200 and 400. So we're going to create those things called nodes and hidden nodes. All right, let's do this. First, we define a constructor, and this constructor will accept the following parameters: accept the features, targets. It will accept the val features and the val targets. Then it will accept the test features and test targets. Then also it will accept the number of epochs, and then it will accept the learning rate. So it's quite a huge one. Yeah, I think that's about it. So that we to define other things. Get the number of rows for the features, and also columns, right? Rows and columns. This will be used somewhere in the future. So self dot rows, self dot calls equals to self dot ft dot shape. So that's about it. For that, we need to get the number of hidden nodes. So you can say self dot hitch underscore 0 equals to a default value. We know they are 130, so we can play around 64. But you can play around 42. So I'm even thinking of using more than one. So self dot h1 equals to 32. Alright, so yeah, I think then we need to define the weights. And now here we will use self dot before that we need to define the output, which is self dot output equals to 1, and self dot weight, but not just weights, it's weight with 0, with 0, yeah. equals to np dot random dot normal, and then here you pass in your scale. So for example, this is scale is equal to 1 divided by self dot calls to power 1.5. Then you say size. The size is equal to self dot calls to self dot h0. And then we do the same thing for the second guy. Yeah, paste that. It's for weight 2. Same weights. And then lastly is for the final weight. This one, weight 2. By h would be that. Paste there, and then here would be output. And we're good. I think from there we are really good. We are fine. So we can define train and just put a self right there up, and then we can just say print. So for example, say model equals to net, and within the net you pass in your train features, you pass in your train targets, you pass in the validation features, you pass in the validation targets, you also pass in the tests features, pass in the test targets, you pass in the number of epochs. So let's say epochs is the number of times you want to train it. So for this one I'll use like 10 for example. Learning rate I'll use 0.01 to start with. You can usually there, but here it's between, usually go from 0.1 and to 0.0001, so you can play around there. So epochs, comma, learning rate, and from there we can run to see if there's any errors. Yeah, so we have a problem with inheriting. I think I wrote double M. Everything should be fine. Yeah, everything is fine. Now let's say for example we need to know like model how weight 0 looks like. Just run it. You can see, so these are random weights. Yeah, so for the next one, the next video, we're now going into details on how to train, because we have to have two functions, one for training and one for testing. So we need two functions: define test itself. Here it will accept two arguments, whereby it will accept the mean. Yeah, let me just write that as mean, and also express the standard deviation. So now it just prints nothing. So these are the two last functions that we need for us to complete this project, and we will speak in the next video.